The Russian heavy nuclear-powered missile cruiser Admiral Nakhimov has been recognized as the fastest large warship in the world. This conclusion was reached by the American publication Military Watch magazine, which analyzed the performance characteristics of the modernized Project 11442 Orlan ship. The cruiser reaches speeds of up to 32 knots, easily outpacing any surface vessel in service with the US and NATO countries. This includes all classes, from destroyers and frigates to amphibious ships and nuclear-powered aircraft carriers. Moreover, the Admiral Nakhimov's displacement reaches 28,000 tons, almost 3 times that of NATO's most powerful surface combatants, the US Arleigh Burke-class destroyers, with their 10,000 tons. The publication emphasizes that such performance is made possible by a unique propulsion system. The cruiser is equipped with 2 kilonewtons 3 reactors, which generate approximately 140,000 horsepower through steam turbines. Admiral Nakhimov remains the world's only operational nuclear-powered surface combatant, and American analysts note that the Pentagon is currently only planning to implement similar technology on the advanced BBG-X program ships, whose future remains uncertain. The key advantage of nuclear power, according to the authors, is its virtually unlimited cruising range. While conventional warships lose speed and endurance as fuel is consumed, the Admiral Nakhimov can maintain maximum speed over any distance without replenishing supplies. This allows the Navy command to quickly transfer the ship between theaters of operations, reinforce forces in crisis regions, and intercept adversaries before they reach key positions. Speed is of particular importance in the Arctic zone and the North Atlantic, where Russia concentrates its main naval forces, and distances are measured in thousands of kilometers. The publication points out that rapid maneuvering directly increases the ship's survivability. It makes it more difficult for the enemy to lock onto a target, while the cruiser itself reduces the time it spends in fire zones and can change launch angles after firing long-range missiles. Earlier, the military publication Military Watch magazine published a comparison of the Russian Project 1144 Orlan heavy nuclear-powered missile cruiser Admiral Nakhimov and the American stealth destroyer Zumwalt, assessing their sizes, armament, and combat potential. On the other hand, the Kirov-class nuclear-powered cruiser Admiral Nakhimov has been confirmed to have integrated a new air wing comprised with modern Ka-27M anti-submarine warfare helicopters. This is particularly significant not only due to the considerable requirements for anti-submarine capabilities under the Navy's Northern Fleet, but also because Kirov-class cruisers were built to accommodate the largest embarked aviation component of any non-carrier surface combatant. While most modern destroyers and cruisers operate a single helicopter, the Kirov class is the only one that was designed from the outset to embark up to 3 Ka-27M or Ka-31 heavyweight helicopters in a dedicated below-deck hangar. This reflects the Kirov class standing as by far the largest surface combat ship in the world, at 28,000 tons, which makes it around triple the size of most destroyers and larger than many aircraft carriers. Anti-submarine warfare helicopters are highly valued for their ability to tremendously expand the detection, tracking, and targeting capabilities of modern surface combat ships against submarines, with the Admiral Nakhimov's unrivaled air wing of 3 such aircraft, combined with its own formidable anti-submarine capabilities, making it in many respects the most capable combat ship for such roles. With hull-mounted sonars constrained by ships' positions and by underwater conditions, the ability to deploy helicopters to rapidly investigate contacts hundreds of kilometers away provides a far greater reach. Helicopters' high mobility allows them to rapidly deploy dipping sonars to multiple distant locations to build an accurate picture of hostile submarines' positions, and can also deploy sonobuoys to establish wide-area acoustic search fields far beyond the range of a ship's sensors. By deploying dozens of passive and active sonobuoys over a large area, a helicopter can monitor submarine movements, triangulate contacts, and relay targeting information back to the ship or to other naval forces. The Ka-27M is an extensively modernized variant of the Soviet Ka-27 that replaces nearly all of the original's mission systems to achieve far superior sensor integration and network-centric capabilities. Its new digital mission system that integrates all onboard sensors into a single tactical picture, allowing sensor data to be fused in real time and enabling crews to detect, classify, and track submarine contacts more quickly and accurately. Its new Copia radar provides a substantially greater detection range, improved resolution, and better reliability, and can simultaneously track multiple surface contacts while also detecting low-flying aircraft and helicopters for maritime surveillance. Its sonobuoy processing system can analyze far larger quantities of acoustic data simultaneously, distinguish submarine signatures more effectively from background noise, and automatically classify contacts, allowing cruisers' air wings to keep up with advances in developing newer, quieter submarines. Sensor and data sharing capabilities allow the aircraft to relay precise targeting data back to the cruiser, allowing it to employ long-range anti-submarine weapons such as the Otvet missile system against contacts well beyond the ship's own sonar horizon. Once a submarine is located, Ka-27M helicopters can attack it directly using lightweight anti-submarine torpedoes, or alternatively can signal the cruiser to move into weapons range. A helicopter can also fly directly to the contact, release a torpedo, and begin another search while the destroyer continues its primary mission. This rapid response significantly shortens the time between detection and engagement, reducing the submarine's opportunity to escape. Helicopters also provide a destroyer with the ability to pursue submarines independently of the ship's own movements, which could be particularly valuable if engaging multiple dispersed hostile submarines simultaneously. The importance of anti-submarine warfare helicopters has increased as submarines have become quieter, with the very low acoustic signatures of modern vessels making them challenging for ships alone to detect, even for vessels as large and well-equipped for such operation as the Admiral Nakhimov. Anti-submarine warfare capabilities are particularly critical for the Admiral Nakhimov due to the expectation that the Arctic, the North Atlantic and the Norwegian Sea where the ship is assigned to operate will become one of the world's most submarine-intensive theaters in the event of a major conflict. This is because the region is central to Russia's strategic nuclear deterrent, with a primary objective of hostile Western submarines expected to be the monitoring, tracking and destruction of the Russian submarine-based ballistic missile deterrent. While the Kirov-class air defense and anti-ship missile capabilities are in many respects world-leading, in the Arctic its anti-submarine warfare capabilities may well play the most significant role.